All right, last time we talked about functions, domains and ranges, and what they are. Memorize those functions because the next chapter, they're going to be very important when we start doing transformations. Because knowing the basic library of functions, and if I give you a transformation, you always look, where does that equation start from? What's the basic graph of that function? And then from there, we move it left, right, up, down, big, small, short, tall. But you have to know those basic functions first. So start memorizing them. I will have a quiz next time on them, just to see how much we remember. Today, we're going to do three things, really. We're going to continue chapter 1. We're going to finish it, actually. We're going to talk about equations of lines, finding them, solving equations of lines, that's what I'm going to call EOLs. And then we'll talk about linear inequalities. That's the crux of today. Didn't we go over the equations of lines last time, the three different types? Well, it's just in case not. All lines come from a point and a slope. So that's the minimum information you need to find the equation of a line. You need to have a point and a slope. So if I give you 2 points, what would you do first? Nope. I'm finding equations, not graphs. Remember? Exactly. Because if we had 2 points, we could find the slope. Now we have the basic information. We have a point and a slope. So again, so that's why this is the basics. There are 3 types. Or instead of types, I could say forms of lines. And they all come from this equation. Uh-oh. Yeah. They all come from this equation. It's the slope equation, of course. You're going to learn in this class that whenever you have fractions and equal sign, get rid of the fractions first. How do you get rid of fractions? No, we can't simplify. But as we're trying to do simplify. But how do we get rid of the bottom number? We have this top number and this bottom number. How do we get rid of the bottom number? Yes. Multiply both sides of the equation by the denominator, or the least common denominator. So if I multiply both sides of this equation by x2 minus x1, on the left-hand side, we now have y2 minus y1 equals I'm showing you this because you don't really have to memorize all these formulas. Since you already memorized the slope formula, I'm showing you how to get the rest of the formulas. It'll save your brain space for something more important. So remember I said, you have a point. The point we have is x1, y1, and then we have a slope. Since x1, y1 are given, that means we don't need x2, y2. That's what we're going to find. So here is our first equation. Can you guess what it's called? Let me give you a hint. It's called the point slope form, right? This is called the point slope form. As you can tell, mathematicians are not too creative. That's our first form. If you're asked to find an equation of a line, you have to be told what form you want it in. If they want it in point slope form, all you do, if I give you, let's say, if given a point, let's say 2, 5, and the slope if you're given that information, find me the equation of the line in point slope form. What would you do? Yeah. This is x1, this is y1, and that's m. So we would have y1 is 5, m is 3, and x1 is 2. And there you have it. You have an equation in point slope form. Let's look at the second form. From here, solve for y. What's the first thing you have to do? Exactly. We have to get rid of the parentheses. So we have to distribute the 3. Because you can't do anything else unless all the parentheses are gone. So 3 times x is 3x. Positive times negative is negative. 3 times 2 is 6. Then what do you do? Exactly. Add 5 to both sides because we have to get the y by itself. So the 5's cancel. Negative 6, positive 5. So negative 6 is bigger, so it's negative. 6 minus 5 is 1. And there we have our second form. This form looks like this. M is the what? And B is the, why is it the y-intercept? No. Actually, the y, fortunately, it was lucky, but the y here is -1. That's not what we had over there. It is the y-intercept, but why is it the y-intercept? How do you find the y-intercept? What do we do with the x? Set it equals 0. So when you set it equals 0, it's gone. Whenever you have a constant term, that's always the y-intercept. A constant term is always the y-intercept. We have y equal m and m, the constant term. So this is the y-intercept. So can you guess the name of this form? slope-intercept. This is the slope-intercept form. And I just showed you one way of finding the slope-intercept form. Put it in the point slope form, then solve for y. That's one way. There's another way. It's kind of a shortcut. Because the only thing we're missing is we have a point and we have a slope. We just don't have b. That's what we use to solve it. Oh, so from the slope-intercept form, move all variables to one side. Remember, what are our variables here? X and Y. Because remember, M is a number, it's a slope. B is the y-intercept, it's a number. The only variables we have are X and Y. So what do? We have to get, in other words, what that says is get all X's and Y's on the same side. That's what it's saying. How do we do that? Are all X's and Y's on the same side? Yeah, so we have to subtract mx from both sides. So we have negative mx plus y equals b. This is a rough form of what we call the standard form. There is the standard form. When you have X's and Y's on one side and the numbers on the other side. But there's one stipulation. Don't do it yet because we're not finished yet. There's still one more thing we have to do with this equation. The leading term, the leading coefficient, A has to be positive. So in this case, whatever's in front of the X has to be positive. What do we do here then? Change all the signs. Just change all the signs. So now this becomes a positive X. That changes to negative to positive. This changes from positive to negative. And this changes from positive to negative. So this is really what it's going to look like. So this is the standard form. So back to our last example. Put that into standard form. So that's the first thing I want you to do. Second is tell me what A equals, tell me what B equals, and tell me what C equals. So what's the first thing you have to do? Move the 3 over. So I subtract 3x from both sides. I have negative 3x plus y equals negative 1. Second step. Is it in standard form? Why not? Because the leading term is negative. So we change all the signs. So that becomes positive, negative, positive. So what's A? 3. What's B? And what's C? Right? Perfect. A, B, and C are only what's in front of X and Y and the constant. That's what A, B, and C are. Since there's nothing in front of Y, there's a negative sign, there's always an invisible 1. There's an invisible 1 in front of everything, below everything, and on a power of everything. There's 1 everywhere. Find the equation of the line in standard form of these 2 points. What's the first thing we have to do? Because remember, in the question, there are 2 clues. First, we're looking for an equation of the line. What do you need to find an equation of a line? You need a point, and you need the slope. We have 2 points, so we can choose either one. Doesn't matter which one. So we have that checked. Do we have a slope? So we have to find the slope. That's the first thing. The next thing it tells us in the form, what does this standard form look like? Because you have to know what the final answer is supposed to look like. It's in standard form. What is standard form? Because you have to know what you're given, what you need, and what you are looking for. It's all in the question. So our first step is we have to find the slope. y2 minus y1, x2 minus x1. So here's x1, y1, x2, y2. Negative 4 minus y1 is 4. Negative 2, net 5 is negative 5. Minus x1 is 3. Negative 4 minus 4 is negative 8. Negative, they're both negatives. 5 plus 3 is 8. The negatives cancel. 8 divided by 8 is 1. So my slope is 1. So I have a slope. Do I have a point? Which point do you want to use? Yes, they're both, doesn't matter. But this has got negatives in it, so I try to keep away from it. If you have one, if you have a point that has a 0 in it, use that because that takes care of some of your variables. If you have positives versus negatives, take the positives. So I'm going to use the point 3, 4. How do I get it to standard form? From what equation? Because all you're given is a slope and a point right now. Yeah, so if right now, what would be the easiest form to put it in? And the easiest would be slope intercept. Because you have, I mean, yeah, point slope. Yeah, because you have a point and you have slope. So put it in point slope form. What does the point slope form look like? So we have y minus 4, 1, x minus 3. This is my x1, this is my y1. It was even labeled that way up here. Given 2 points, find the slope. Choose either point. Plug into point slope form. And solve for the equation of the line you're looking for. So these are the steps. First thing you have to do is get rid of the parentheses. One times x is x, positive times negative is negative, 1 times 3 is 3. What do you move now? We got to move the x to the other side, yes. We have negative x plus y minus 4 equals negative 3. What else do we got to move? We got to move the 4. It's a negative 4, so we add 4 to both sides. Negative x plus y. Since 4 is bigger than 3, it's positive. 4 minus 3 is 1. Last step. Because remember, it has to have a positive here. So we just change all the signs. X minus y equals negative 1. And there's your equation in standard form. So if you're given 2 points, you can find the slope, choose either of the points, plug it in there, take it from there. Because once we have a point and the slope, we plug it in there. We plug it in the point slope formula. And then we can go anywhere we want to. We can find the standard form by doing what we just did. Find the slope intercept form. Find the equation of the line in slope intercept form. It only takes 2 steps in this case. What's my first step? Always get rid of the parentheses. Whenever you're solving for anything, get rid of parentheses. is 4. 1 times x is x. Positive times negative is negative. 1 times 3 is 3. What does slope-intercept form look like? Very good. In other words, we have to get y by itself. Again, knowing what you're looking for is half the battle. Because once you know what you're looking for, getting there is just moving things around. So how do we get y by itself? Add 4 to both sides. Very good. 4 is bigger than 3, so it's positive. 4 minus 3 is 1. And there you have it. Pretty straightforward. So that's the problem of finding equations of lines. That's all there is to it. It sounded so difficult in high school. Let's go to the next topic now. Comparing. We can also find equations of lines from graphs. In all 3 forms. Find the equation of that line. What do you think the first step is? Exact. Excellent. Find 2 distinct points. What I mean by distinct is dots that are exactly at where 2 numbers intersect. Or 2 lines intersect. If it's not on the exact cross where they intersect, don't use that point. Find one that really works. Okay, second step. Actually, what are our points here? 1, 4. That's first points. Very good. That's point 1, and this is point 2. Second step. How would you find the slope? You could do that. Yes. One way of doing it is y2 minus y1, x2 minus 1. Because you have the 2 points, you can plug in and work it out. Or you can get it from the graph. is from point 1 to point 2, is it going up or down? It's going down, so it's negative. How far is it going down? How many steps? Yeah, it's going 1, 2. And the bottom is how far do they go from x1 to x2? 1, 2, 3. And there's your slope. Because really, we haven't done anything mathematical yet. We have a slope. We have 2 points. Third step is what? You're supposed to pick a point, doesn't matter which one, and then plug the slope and the point into the point slope formula. So I'm going to use the 0.14. It doesn't matter which one you choose, because it's going to give you the same answer. And we know the slope is -2 over 3. So A, the point slope form. That's y minus y1 equals m x minus x1. This is x1, this is y1, so it's y minus 4, -2/3 x minus x1 is 1. And there's the first form. There's our first answer. This is our first answer. How do I get to the next answer? Next form. What is the next form? The slope-intercept form. What does the slope-intercept form look like? So that means we have to start from here, solve for y. So we have to solve for y. We have to multiply first, get rid of the parentheses. Negative times positive is negative. 2/3 times x is 2/3 x. Negative times negative is positive. 2/3 times 1 is 2/3. Then we have to get the y by itself, so we add 4 to both sides. Here we have 2/3 plus 4. It's actually 4 over 1, because it has to have fractions. How do we add fractions? The butterfly method. I love the butterfly method. Well, yeah, but this is easier. Whenever you ask, but yeah, you have to have common denominator. Yes, this is what we're going to find for you. The butterfly method works for addition and subtraction. It kind of looks like a butterfly. Multiply these two. So 2 times 1 is 2. It's a plus sign. 3 times 4 is 12. And on the bottom, 3 times 1 is 3. So on top, we have 2 plus 12 over 3. So it's 14 over 3. You can use whatever method you want, but I really like this because it does everything for me. I don't have to write 4 over 4 or 3 over 3 or whatever. It does everything for me. Multiply diagonally, multiply the bottom numbers, and just add the products. So it's positive 14 over 3. Most of y'all, how many of y'all don't mind working with fractions? You're like me, I hate fractions because too many chances of errors. Let's start from this step. I'll show you what I do. Or we can so we're starting from that line. Get rid of the fraction. And this is what we're always going to do. No matter when we have fractions, we're going to get rid of the fractions. And if there's a final answer as a fraction, it'll be a final, in the final step, it'll be a fraction. So we don't have to worry about it ever. First step. Find the least common denominator, the LCD. So in our case, what's the least common denominator? What is a denominator? We have a numerator and denominator. So we're looking, denominator is a bottom number. And since we only have one fraction, it's the only denominator. So the LCD in our case is 3. So whenever you have fractions, find the least common denominator. The next example I'm going to give you all of them be fractions. So this is just a simple one that we're going to do it first. So first find the LCD. Multiply the LCD to each term. Remember, what is a term? A term. Anything separated by a plus, minus, or equal. That's a term. So here's the 1 term, 2 terms, 3 terms. This, on the other side, on the right-hand side of the equal sign, is one big term. So we multiply the LCD to each term. Basically, all I'm doing is I'm putting the LCD in front of each term. That's all I'm doing. Whenever you have fractions and multiplication, always reduce first. Cancel anything you can, top and bottom. Can anything cancel here? No, there's nothing on the bottom. How about here? This 3 and that 3 can cancel. Since there's nothing else in front, I don't need that. Doesn't that look easier now? These two are still the same equations, except that one looks a lot easier. Remove parentheses and simplify. Then the last step is solve for y. These are the 5 steps that are always going to be used whenever you have fractions and equals. All right, so we reduced, we got that. Remove parentheses. So 3 times y is 3y. Negative times positive is negative. 3 times 4 is 12. Negative times positive is negative. 2 times x is 2x. Negative times negative is positive. 2 times 1 is 2. Can we combine like terms on either side? It's all done. So nothing we do. Solve for y. What do you have to do to solve for y? Well, get rid of this first. Get rid of plus and minuses first. Since we're solving for y, we have to get rid of anything plus or minus. So we add 12 to both sides. They're both positive. 12 plus 2 is 14. Last step, divide each term by 3. And there's our answer. If the answer is supposed to be a fraction, it'll be a fraction at the last step. You want to try another one? This time with all fractions. I'll get a clean page here, so we have the whole sheet to work on. So the point we're using is 1/3, 2/5, and the slope is 2/3. Find the equation of the line in slope-intercept form. The first thing we have to do is plug this thing into our point slope formula. This is x1, this is y1, that's m. 2/5. M is 2/3. X1 is 1/3. We have fractions everywhere. First step. What's the LCD? In other words, what's the smallest number that 3 and 5 both fit into? What's that? 50. Yeah, if you multiply them together, 3 times 5 is 15. That's if you don't think about it, just multiply them together and that'll work also. Because 3 times 5 equals 15. That's the easiest way you can do it. So second step is multiply the LCD to each term. In other words, what that means is put it in front of each term. So you have 15 times y minus 15 times 2/5. 15 times 2/3 x minus 1/3. This 1/3 inside here you can't touch because it's inside the parentheses. You can only multiply stuff outside the parentheses. What's the third step? Reduce where you can. What can you do here? How many times is 5 going to 15? 3 goes into 5. 5 times. Okay, it's looking a lot easier so far. So in other words, at this step here, this is where you get rid of all the fractions. At this step right here. After you multiply by the LCD, that should get rid of all your fractions. Multiply to remove the parentheses. 15 times y is 15y. Negative times positive is negative. 3 times 2 is 6. 5 times 2 is 10. We have to multiply again to get rid of the parentheses. So positive is positive. 10 times x is 10x. Positive times negative is negative. 10 times 1/3. What is 10 times 1/3? Yeah. Nothing cancels, so it's 10 times 1 is 10. 1 times 3 is 3. It's 10/3. Again, we have a fraction and we have an equal sign. What's the LCD? What's the only, the only denominator is 3. Multiply the LCD to each term. So put it in front of each number. 3 times 15y. 3 times 6. 3 times 10x. 3 times 10 over 3. Reduce. Nothing there, nothing there. The 3's cancel. And all we have left is 10 there. No more fractions. Was it painful to get rid of the fractions already? It wasn't painful. It's just 2 steps of just canceling them out. Wasn't anything difficult. The only thing difficult part was finding the LCD. That's the hardest part of the first step. Now we have to multiply to get rid of the parentheses. What's 3 times 15? 15 times 3. 5 times 3 is 15. Carry the 1. 3 times 1 is 3 plus 1 is 45. Three times 6 is 18. 10 times 3 is 30 minus 10. The last step is solve for y. Add 18 to both sides. Why can I not add 18 to the 30x? Yeah, it's not like terms. This one's got an x, this one doesn't, so I can't combine them. Apples and oranges. So 18 is bigger than 10, so it's positive. 18 minus 10 is 8. We're solving for y. We have to divide by 45. Are we done? Why? Yeah, if you can simplify, you're not done until everything's simplified as far as possible. Do 30 and 45 have anything in common? 5s. How many times does 5 go into 30? 6. And then 5 goes into 45 9 times. 6 and 9 both have something in common. They both have a 3. 3 goes into 6 twice. 3 goes into 9 3 times. So far, we have 2 over 3x is our first number. Do 8 and 45 have anything in common? No, because 45 is made up of 9 times 5. This is made up of 3 times 3. So neither 5 nor 3 fit into 8. So it's 8 over 45. There's your answer. It's a lot easier doing it this step because all you have to do at the end is just simplify. comparing two equations. Of course, we're talking about linear equations. There are four possibilities. Looks like the flag of Malta. The first possibility this is line 1 and this is line 2. When two lines look like this, they'll never touch. These are called parallel lines. The symbol we use as a shortcut, we just use those two little hash marks, little slash marks. This one has no solutions. Another one, this is line 1 and this is line 2. They could be the same line. In this case, it has infinite solutions. The third case, this is line 1, this is line 2. They form a 90-degree angle. That's what that means there. 90-degree angle. Like the corner of your paper, that's a 90-degree angle. We call these perpendicular or orthogonal or normal. There are different things you use it for. We use this for in mathematics, but we'll call it perpendicular here. The symbol we use here is the upside down T. This one has one solution. Line 1, line 2. Anything else goes in this last one. And that one only has one solution. To begin with, terms. When I say solution, what does that mean? In this case, what does a solution represent in this case? Very good. It's where the lines intersect, where the lines cross. Where two lines intersect. But there's more definitions of solution. There are 4 more definitions of solution. But in this case, We're going to say solution means where they intersect. Why does this one have no solutions? Yeah, because they're parallel. They never touch. This one has infinite solutions because every point is a solution. They overlap at every point. And these only cross at one point. How do we distinguish them apart? What do we notice? How do we tell if two lines are parallel? Very good. The slope of line 1 equals the slope of line 2. But how about this one down here? What's their slopes? So we can't use slope necessarily. We know if the slopes are the same, they're either parallel or the same line. What differentiates the two? Yeah, it's where they cross the y-axis, the y-intercepts. The y-intercept of one does not equal the y-intercept of the second. So if they have the same slope, different y-intercepts, where they cross the y-axis, they're parallel. But if they have the same slope and the same y-intercepts, they're the same line. But that doesn't work here on these next two. How can we tell them apart? Because obviously we can't use the y-intercept as a comparison because they both have different y-intercepts. Or they could cross on the y-intercept. So we can't use the y-intercept for this one. And they can't be the same slopes. Because if they're the same slope, it's got to be one of these two. So that means the only way you tell these two apart are by the slopes. They're going to have different slopes. So the slope of line 1 doesn't equal the slope of line 2. The slope of line 1 doesn't equal the slope of line 2. But how do we tell them apart? For perpendicular lines, the slope of one line is the negative reciprocal of the second line. The slope of line 1 is the negative reciprocal. In other words, if the slope of line 1 was 2, the slope of the perpendicular line would be negative 1 over 2. You flip it and change the sign. And anything else is going to be this. It's going to have one solution, and there's going to be any other lines. So if I give you two lines and I ask you to tell me how they're related, how would you do it? How would you find the solution? This is the clue right here. Do we have any equation that tells you M and B? Which one? Slope intercept. If I give you two equations, put them both in y equals mx plus b, and compare the slopes. If the slopes are the same, it's got to be one of these two. If the slopes are different, it's got to be one of these two. If it's one of these two, look at the y-intercepts. If they're the same line. If they're different, they're parallel. There's no solution. So that's all you have to do is when I give you two equations, solve them both for y and compare the slopes and then the y-intercepts. I want you to tell me the slope parallel and the slope perpendicular. I'm gonna give you some slopes and you're gonna tell me what they are. Here's slope of line 1 equals 3. So tell me the slope parallel to it. Because it's the same. What's perpendicular? Because this is 3/1. Let somebody else answer, because you've had all this stuff before. You've had calculus before, so let somebody else answer, because I want to see what they know. So this is 3/1. Remember, the perpendicular is a reciprocal and change the sign. So this is positive, it's got to be negative. That's 3/1. This one has to be 1/3. The second line has a slope of -4/5. What's the parallel slope? Yeah, it's the same thing. It doesn't change. It's the same thing. -4/5. What's the perpendicular? Change the sign. This one's negative, so it has to be positive, and flip it. 5/4. Very good. Slope equals 0. The parallel one's 0. What's the perpendicular one? What is -1/0?
Undefined.
You cannot divide by 0. Here's the reason why. If I have 0/1, how many times does 1 go into 0? 0 times. How many times does 0 go into 1? An infinite number of times. In other words, I can give you nothing forever. That's what this says. This 0 goes into 1 an infinite number of times. That's why it's undefined. You cannot divide by 0. So if you have an undefined slope, the parallel would be undefined, and the perpendicular would be 0. Because if it's undefined, it's 1/0. If it's parallel, it's 1/0. Then it's 0/1. And 0 doesn't have a sign, so it's just 0. And we'll just do some examples of this next time. So also here, also next time we're going to finish the chapter, we're going to do inequalities. So if you're comfortable with inequalities, take one of these. We're going to fill these sheets out next time. And if you're interested, I have a whole bunch of practice worksheets for you if you want to do practice worksheets for inequalities. Take one if you want to. So if you feel comfortable with inequalities already, then you're free on Thursday. Because all we're going to do is we're going to do some more of these examples here. Then we'll do inequalities, and that'll finish chapter 1. So if you're comfortable with inequalities, you don't have to come to class on Thursday. Because it's for you guys. It's, you know it, so it's chomping at the bit. Come on, somebody say the word. All right, everybody. Have a great